corner, and then there might be a camera that's looking and then checking whether it's really hazard. Maybe that was just a false alarm. Then you analyze what's the type of fire, whether it's a burning wall, or it's the carpet, or it's the desk, and so forth. And then you are trying to trigger some event. For example, you can call 911. Or you can call a robot and extinguish or contain that hazard. So you are really trying to put together multiple sensing devices, gather the information, figure out where the sensors are, at what time the measurement was taken, and what kind of hazard is occurring. So if I want to describe the problem, I would say, well, given wired and wireless multi-spectral cameras and other point sensors, assess hazards in an indoor environment. And my inputs are the wired multi-spectral sensors, like a thermal infrared camera, hyperspectral camera, visible and multi-spectral camera inputs. And then I have these point sensors that have onboard processing capabilities, and they can measure temperature, acceleration, luminance, all kinds of variables. And my system requirements are, well, I want to adaptively position these sensors in space and time, possibly switch between sensing temperature and luminance and other variables. Then I want to have minimum wireless loss in the space. So there is an issue with transmission and reception. And then I want to optimally integrate all the data across disparate sensing systems over time and space and provide accurate and fast calibration. If I get a reading 10, I don't know whether it's temperature 70 degrees Fahrenheit or 100 degrees Fahrenheit. I have to calibrate the value. And then I sometimes might get false alarm, or from a security viewpoint, there might be a malicious sensor that's reporting false alarm. I have to have confirmation mechanism and hazard understanding, and then somehow I have to alert humans. Usually in this kind of scenario, there is always human involved. So I have to have some kind of interface to a human, and then possibly develop an application that has the hazard containment component. So the motivation for doing this work is really, from a research perspective, is to figure out certain proactive surveillance system similar to a thermostat. I mean, right? So you don't really know that your thermostat is working at home, but it is switching on and off your heating. There are bandwidth requirement reduction issues. So for example, in this room, if I install here 20 cameras, the bandwidth that I need for those 20 cameras is going to be huge. But if I'm just sensing with these point sensors, it's very low bandwidth, and I'll trigger the cameras only when I know that there is some kind of hazard. So the bandwidth, it's very efficient use of the bandwidth. I also want to introduce spatially adaptive sensing. There might be sensor failure. It might be too expensive to put too many sensors in this room, so I want to be able to reshuffle the sensors in the room. And then I would like to understand the hazard. So when I call 911, I'll say, okay, it's in this room, and it's the furniture that's burning. Please bring appropriate extinguisher. Now, from a technical viewpoint, the challenges are, when you are building a system, you have to worry about the sensor selection and what's the ruggedness, weight, capabilities of these sensors. There are some power, memory, and CPU constraints. In terms of wireless communication, you always are concerned about limited range, delays in transmission, packet losses. How do you deploy sensors? What if we would be deploying sensors in a room that has radioactive material? We don't want to go there. We want to have some remote control over the deployment. Then how should I deploy the sensors? Should they form a grid? Should they be in a straight line? Should they be close to a wall? What's the optimal sensor layout? Then I have to worry about the sensor and camera calibration, camera control. I'm switching. I have multiple cameras, so I want to switch. Which camera is currently broadcasting? I want to have the capability to recognize and detect hazardous event, and then possibly confirm and then propagate the alarm. So maybe I alarm a security guard, but he is sleeping. Am I going to wait for half an hour and then propagate the alarm to his superior? Or how is that mechanism going to work? So this is what we developed so far. This is a prototype. We started with the sensor deployment aspect, which is left middle side of the slide. And then we developed techniques for deploying these MICA sensors that I will describe in the next few slides. Then we started to worry about synchronization of cameras and sensors. How do you synchronize all the measurements? Since we deploy the sensors, we want to know where they landed. So we apply multiple algorithms to localize the sensors. Now we start to acquire data. We want to know what's that measurement, what's the interpretation of the measurement. Is really raw value 10 a hazard, or it's just a regular temperature, ambient temperature? So we have to calibrate spectral cameras and sensors. Then when I turn off the light in this room, you don't want to be sending visible spectrum camera to the operator because he wouldn't see anything. You want to turn on your thermo-infrared camera, and that makes sense. So we have this proactive camera control, which really works without us really knowing about it. And then sometimes you want to be doing regular checks, and you want to go and send a robot and walk into each room and say, well, find and scan the room and tell me if there is any hazard. So there is this hazard detection algorithm that we have in place. And then we are not a really human-computer interface people, but we are trying to figure out how would you build a friendly user interface so the operator immediately sees what's the temperature, whether the light is on or off. He can switch between cameras. He can look at the sensor readings. And then eventually, when he sees a hazard, the hazard will be highlighted in his view so he can make a decision. And then there is the component that deals with hazard understanding and confirmation. I'll talk about it a little bit later. And then eventually hazard containment, which I'm sure will amuse you because we just built it in the lab for demonstration purposes. So when you think about the whole system, it's a combination of research and development. When you think about development, you think about deploying the point sensors using robot control. But when you think about the basic research, you really have to figure out how to control the robot remotely and how to adaptively set up your application. How do you deploy the sensors? When it comes to calibrating cameras and point sensors, again, there is a research component. What is my accuracy? Can I quantify the accuracy? And then can I do it real time? Speed is very important. Then it comes to controlling cameras proactively. It's very important for bandwidth control and information selection. What type of camera I'm turning on. When it comes to the hazard detection, again, there are many issues how to understand the hazard. By just looking at the flame, can you tell what is burning? The alert operator, again, there are research issues with the human-computer interface. And when it comes to hazard confirmation and containment, or you want to eliminate small hazard, in my opinion, these are new applications for robotics because clearly you cannot deploy robots in any scenario. It has to be well-defined. You might know the CAD model of the building or a floor plan and so forth. But it's a research issue how to do that successfully and reliably. So here's the list of technology components that we put together. So we can deploy point sensors, the smart modes, using robot control, using either a human-computer interface, keyboard, mouse, or using speech, or using gesture. And then we have a video feedback from the robot, so we actually can verify and possibly track a few things in the room. Then we have the component that deals with calibration, time, space, and measurement, all the spectral cameras and point sensors. Then we have a component that switches the cameras, which we call proactive camera control, using point sensors between visible and thermo-infrared information. Then there is a component that deals with hazard analysis and human alert, which is really very much related to emergency management and response. And finally is the hazard confirmation and elimination using robot control, which means really we have to go back, deploy more sensors, and we will attempt to contain hazard. Related work. Clearly, the challenge here is that the use of technology components is scattered all over many fields. The wireless sensing devices are frequently used in smart spaces. Ubiquitous and proactive